man, this is really living.
We're committed to the art and nothing stop us, not even a train, plane, tractor, all of us as we feel the rhythm inside the marrow of our bones.
Hey guys, Bukuli here, gonna give you a video. Hey, this was an article written a few years back, well, in 2018. This came into our conversation a few months back. It's about what they call solar tornadoes, and I'm bringing this back up because we're kind of seeing something like that on the SDO right now. I want to show it to you guys and show you what's going on with that, but I want to give you an explanation on what we're actually looking at first, so you guys have a better understanding of what's actually going on. Now, before I go into this, I want to recall or strike your guys' memory here a little bit. A couple videos back I did on that interplanetary shock, being the energy was actually electromagnetic instead of kinetic energy. I will in the future give you guys a little bit more information on what kinetic energy actually is. I don't want to go into that because that's a pretty long conversation. I mean, there's a lot to talk about there, a lot to unpack. So I'm just going to leave that at that for now. But I'm bringing this up because, number one, I am kind of seeing one right now, and they're very, very frequent. They happen a lot. They're not rare at all. But this is another kind of, I guess, a prover point that what we talk about with the electromagnetic fields interacting with each other, like the Planet X object and the sun, and then it actually will cause it to discharge in our direction, and we'll see disruptions on our magnetopause. Okay, and that stuff is traveling, electromagnetically instead of regular solar wind. This is actually, the interplanetary shock that I showed you guys a couple of days back was basically saying, hey, that's possible because that energy is traveling electromagnetically. And this is actually kind of pointing to it too, because they thought that these solar tornadoes, guys, were spinning just like they do here on Earth. And keep in mind, a solar tornado can be 4 to 5 times the size of the Earth. That's huge. Okay, but they've come to find out that they are basically following the magnetic lines, the magnetic field lines that are on the surface of the sun. Okay, it's basically what this is saying, very basic level. That's just an animation of what, solar tornado. Okay, you can kind of see how you would think that would be rotating. But I'm going to zoom in here and show you something. I'm not sure if they did this intentionally, but this is actually how it showed up. Now, if you guys can, let's see here. First off, let's do that. Well, let me zoom in a little bit more. Okay, can you guys kind of see the lines that are actually going through here? And again, this is an animation. This isn't an actual capture. So that would be like your magnetic field lines, and these things are traveling on those lines. Now, that doesn't mean that they're spinning real fast like a wind does, because that's what I'm trying to explain to you here. Okay. Now, obviously they were formerly known as tornado prominences. Okay, but we call them solar tornadoes. So they're gigantic. Obviously, they're 4 or 5 times the size of the Earth. But here's the issue. Okay. Ultimately, they're driven by nuclear reactions in the solar core. Okay, basically the core of the sun. They're driven by the nuclear reactions that happen there. Okay, but here's a key point. They're made of hot, flowing gas, entangled magnetic field lines. That's what I just showed you guys. Now, these hot, flowing gases are also magnetic themselves. That's why they travel those lines. Now, if you guys remember back, Scott did a video, and I piggybacked on it some, that he was theorizing that the object that he's seen was covered in like a gas cloud, and it could have its own electromagnetic field also. have a magnetic field also, just like the sun, the earth, and all these other objects. Basically, everything can have a magnetic field, okay? But the gas can too. So these things are traveling magnetically. So I wanted to point that out because it just tells you that more and more things we're finding out, and it's becoming more and more accepted even into mainstream science, that things are more traveling electromagnetically through field lines and stuff than they are what we traditionally thought. So the stuff we talk about is very, very possible, all right, as far as these objects interacting with each other, causing these disturbances that we can't explain. Because if we see stuff on the models and we can't look at the sun and say, hey, there's a coronal hole, then where did it come from? Where did energy come from? Cosmic rays, possibility. But then we got all this other stuff that we got to take in consideration. So I'm just showing you guys this here because this is showing that at least one more thing here is traveling magnetically. All right, it's not kinetic. It's not any of those other kinds of things. But yeah, it's not just blowing around like we typically thought it was. So, and here's why. It's an optical illusion, optical effect. Okay, if you guys read on to this, okay, they added the SDO. We see that stuff in 2 dimensions, guys. It's a 2-dimensional model. It's not 3-dimensional. All right. It's all those models we use basically are 2-dimensional. So we have to try to think of them in 3 dimensions to get the proper view of it. And it's hard to do sometimes. It's hard to wrap your brain around that. So this is why they thought they were doing that until they added this 3rd measurement using Doppler effect. Okay, and that's what led them to, says a more complete picture of the magnetic field structure. In other words, the magnetic house it was in, it gave you a better picture of it, right? So that supports the plasma according to this statement. Okay, this is what's going on in this article. Now, it says, compared to tornadoes on Earth, which are formed intense winds and very mobile, solar tornadoes are composed of magnetized gas. You guys hear that? Magnetized gas that appear to be deep-rooted in the solar... what's it say here? Sorry about that. Deep-rooted in the solar surface. Okay? Therefore, remaining in a fixed place, the researchers said. In other words, it's in a fixed place. It's just traveling back and forth on that magnetic field line, right? It's all traveling, intertwined field lines. That's why they look as if they're swirling, okay? Obviously, it says they're associated with solar prominences, active areas on the sun. That's when we see them. So, I wanted to bring that to you guys real quick. I'm going to take you guys over to SDO. Hold on a second. All right, guys, I'm back. I'm going to show you this real quick. What's it doing? What the heck? It's ridiculous. Okay, what we're looking at is up here. Okay. Now, it is right up in here. You guys will see this little vortex form. This isn't probably the best one to show it to you guys on. It just gives you more detail on this one. Actually, what I'm going to do, I'm going to pause again, guys. Sorry. Okay, guys, I'm back again. Anyway, this is the SDO, and you're going to see, watch up here. Okay, if you watch real close, you'll see it actually stretch back out right here. Alright, here it goes. Right there. So, what you're seeing there is a solar tornado. You can actually see multiple ones of them right here. If you look up here, look at right here, you'll see it happen. See how it looks like it's spinning? Okay. But as we just read, it's following those magnetic field lines. Okay, those field lines magnetically. That's why I'm showing it to you guys. But this right here, to go into this a little bit more, this is if this is to go ahead and release, and it could, okay, it looks as if it's going to. Now, I don't know if it is or not, but it has to escape the gravity of the sun. If it does that, that makes it a CME. Okay, that's what I've tried to explain before in the past. The CME is mass from the sun getting ejected, right? A solar flare is light, basically, because it travels at the speed of light. Now, like again, this is a filament that if it comes off hard enough, it'll be a CME. Now, this isn't Earth facing, it doesn't look like. Okay, what do I mean by that? Back up, okay? We're looking directly at it. Our view is looking directly at this. Okay, so this would be off, if we went outside and looked up, it would be off to our upper left, okay, fire in that direction. Now, what I find interesting is we see activity there on that limb here, 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 and here a lot. Okay, sometimes we'll see it on the equators, very, very seldom, and very, very seldom do we see it on the poles of the sun. Seems as though those 4 areas I showed there at first are more active, and I typically don't know why, guys. So I need to look into that, ask Scott about that, see if he knows why. It might probably just take a little bit of research, and I could probably figure out what the reasoning is. I just haven't done it yet. But as you can see, if that filament releases on out, it doesn't mean it's going to be powerful. It just means it's large in size. Okay? Because that ain't what makes it powerful. It's large in size. The speed and the density of it is what would make it powerful, right? But also, if you go over here to that other area, on the right side of the sun, watch this. Boom. Okay? I think most definitely that was a CME, but it wasn't Earth facing. Okay, this is all happening right now within the past 12 hours. This is like a 12-hour loop. So probably back as far as 16 hours because there's like a 4-hour lag here. Okay. Now it looks like that popped off pretty violently. Looks like it happened twice. One from one side, one from, see, look at that. Now I'm not sure if it did or not. I don't, it's hard to tell sometimes. It's not Earth facing, so it probably really doesn't matter. But this here, what concerns me about this one, guys, is that if that didn't release and all that energy's still there and it stays active, it's rotating towards the Earth strike zone, or at least Earth facing. If it gets, if that active area stays together and it gets about right here and it has one of these, then we better be looking at the Earth for CME, okay? That's not what happened right here yet. But in the next couple days, that active area will rotate through to be Earth facing. Now, you can have a CME happen like right here and get fired off this direction. If that happens, that means it's getting fired right off at the Earth, right? So that'd be an Earth-directed CME. It doesn't necessarily have to be in the middle of the sun for it to be Earth facing. We all kind of think that most of the time, but it's not the case. It's directional. It depends on what direction it actually gets fired off of the sun. So when the sun does react with other objects, that's why it looks as if it's going a different direction, if that makes any sense. So anyway, I wanted to show you guys that. I am going to take you over and let you see the 304 on the SDO real quick. It'll only take me a second here to boot that up. That's what's nice about the SDO. The definition isn't as good as what it is over on ISWA, but you don't get the, you don't get the speed, you don't get the ability to go back and forth between angstroms like this. You have to boot it all up separate, and it takes forever to load and everything else. So, but that's why I'm using this one. Okay, this is the 304. Now there's our filament. Okay, you see what it does? See how it kind of turns into like a vortex there? Starts out a vortex, kind of shoots across and turns into another. All right, now if any of that gets released off, that would be a CME. Okay, and it could. Now this one over here looks more like a typical CME because it's a flicking action. Okay, watch. See that? See how fast that was too? that means it was moving pretty quick. I think that flipped on off. I really do. I think some of that made it out. Now that would be out, again, not earth facing. So just wanted to point that out. But yeah, we are seeing some stuff on the models just a little bit. Excuse me, guys. Sorry. I'll take you guys over here to space weather real quick. And again, setting the solar wind speed's 381. No geomagnetic activity actually going on there. This is what kind of puzzles me. Okay, now we're seeing the solar wind kind of decrease below 500 there. All right, so it is kind of consistent with this one over here. Now that one there doesn't look like it was even at 500 at all. So I don't know, and these models kind of differ sometimes. What am I looking at there? I'm looking at the green line. Oops. Sorry about that, guys. Stupid ads. Anyway, yeah. So they're not really predicting a whole lot in solar wind for the next 5 days. We'll have to wait and see, right? If we start seeing those models go crazy again, then we got to start asking questions, right? So, but anyway, guys, I wanted to bring that to you. I'll give you guys an update. Also, I'm going to put, instrumental music at the end on my model update stuff that I've been doing. And if you guys want, we can play a little game, see if you guys can't guess the song. I'm sure people my age will know it. There's a hint at the end of the song. Because there are no lyrics. There's a few little chorus lyrics at the end, which would pretty much give it away to anybody that's ever heard this song before. But some of the other stuff I'll be playing and played before, it's kind of fun, I think. Hope you guys enjoy that part of it while you guys are looking at the models. Give you guys something to listen to while you're looking at the models. So anyway, guys, I think I am going to end it right there. God bless. Yeshua saves, and you can drink this Kool-Aid.